exponential growth and decay. This goes with the textbook 16.2. Your essential question: how can you use exponential functions to model the increase or decrease of a quantity over time? And so growth and increase, those correlate with each other. They mean the same thing. Decay and decrease, those two correlate with each other and they mean the same thing. And so your learning goal is still the same of I can graph an exponential function. And this first slide here, this is a review slide. Okay. We're going to use the Desmos graphing calculator for this. We have a exponential function right here because it has f of x on the left, and on the right hand side we have a times b to the x power. This is an exponential function where you have an a, a b, and an x power. So what we're going to do is use Desmos. We're going to type this in. I'm going to show you how to fill out this table a lot quicker than what we were doing before. Before we were doing it by hand, remember? We were replacing the x value, -2 here, and then 2 to the -2 power became 1 over 2 squared. And then, we simplified it after that, always using PEMDAS order to evaluate all these exponential things here. The 0 power is a real easy one. Anything to the 0 power, that's always just 1. Right, so if I put a 0 here, 2 to the 0 power is 1, and then then 4 times 1 is just 4. So some of these are real simple to figure out. You can use some like text tool here. This one I know is 4. That one's easy. These negative exponents, they get a little tough, but you can do them. You just follow the different rules that we have. If x is 1, 2 to the first power is 2. Okay, Hermosa. Thank you for letting me know. So 2 to the first power is 1. 4 times 1 is just, 2 to the first power is 2. 4 times 2 is 8. Okay, so you can kind of see these get big real quick. 2 squared is 4. 4 times 4 is 16. All right, so you guys are working on this slide right now. And I'm going to kind of force open a tab for you. We're going to open up the Desmos graphing calculator. So Desmos graphing calculator is coming at you. What you need to do is type in f of x equals 4 times 2 to the x power. You need to be real familiar with using the Desmos graphing calculator because I want you to use it on our test this Friday. And you can even use it on our test on Monday. You can use it all the time. It's a really good tool to be proficient in so you do well in your math class. All right, so that screen should have popped up. If you want to split your screen so you have the graphing calculator, you have the Google Meet, you have your Pear Deck tab, you have all these different tabs that you have 3 right now that you need to have open. So now I'm going to type in f of x. And my cap lock on. I'll try that again. F of x equals. All right, so you just type 4, open parenthesis 2, close parenthesis, and then to get your exponent of x, if you don't remember, you can come down to the keypad and you can click on the button in the top row. That's a to the b power. That's going to move your exponent to where it needs to be. And then you can type x. And you should have this picture right here shown, like I have. Okay, so check with the Google Meet and what you wrote on what you typed in on the graphing calculator to see if it looks the same as mine. And right now I'm on the default Zoom. Okay, so if you zoomed in or zoom out, it might look a little different, but if you click the little home button, it would go back to the default zoom. So this is what we're going to be graphing. And here's a really cool thing you could do. So I told you there's an easier way to get your table. Okay, so come back to the Google Meet. I'm going to show you how to get your table really, really easy filled out. Come back to the Google Meet. And so I'm going to come up here to the settings wheel where it says edit list. I'm going to click on that. And then it brings up, it looks different now. And so this is also where you can change the color of your graph by clicking on the dot if you wanted to. But if I click this convert to table button, watch this. Boom, there's all the answers. Wow, isn't that fancy? So I did these ones correct, right? 0 is 4. When x is 1, I get 8. When x is 2, I get 16. Like I said, the negative ones take a little bit more work when you work them out, but if you do them by hand the other way, you should get 1 and 2. So we'll finish filling in our table using the table from Desmos. And then what we're going to do is plot. And you can see once I put it into table mode, it actually plotted the 5 ordered pairs that are listed here. So if I click on one of the points, it shows me the coordinates of that point, -2, 1, which correlates to this first row of the table, -2, 1. So you're going to go through and you're going to plot the same 5 points on your graph in your paired X slide. Pay attention to the scale. Okay, so the 2 graphs, the one in Desmos and the one in the Pear Deck, they're different scales. So they won't look exactly the same because the scale over here in Desmos, the x-axis, every unit square is actually worth 1/2. And that's horizontally on the x-axis. Vertically on the y-axis, each unit square is worth 2. So it's going to look a little bit different. Whereas over in the Desmos graphing calculator, depending on which level of zoom you're on, it can change. All right, so if you zoom in a little bit, it would change. If you zoom in again, it would change again. All right, but you can click on any of the points over here to see what those coordinates are. And then you just have to plot them correctly on your Pear Deck slide. And to plot points, I just use the pencil tool in Pear Deck, and then I change the size of it so it's about this big. And then it'll make these perfect little round plotted points for me. 1, 8. You can also use the table, 1, 8. Lots of ways to get this done. And you should get familiar with Desmos graphing calculator so you can use this to help you on Friday and on Monday. Monday, you're going to have another one where you graph an exponential function. You had one like that on the last Unit 3 test. Okay. Unit 4 is like an extension of Unit 3. That's why we're going to go back and retest on Unit 3 and also review just those test questions. 216. All right, so once you get all 5 points, it should look something like mine. I'm going to reset that to home. And you're going to use the pencil tool to then draw a line through these points. Now, you want to just try your best to touch all the points. And probably when you draw the line, you want to make the size smaller than you had for the points, so you can still see those points. All right, it's not going to be perfect, but in Desmos, no matter how much I zoom out, I never get those arrows at the end because in Desmos, it's like infinitely going on forever. But my picture doesn't go on forever like Desmos, so I do need to put arrows at the ends of my graph to show that they go on forever in both directions. Don't forget your arrows for Desmos. The next thing we're going to do is identify A and B So this right here, f of x equals 4 times 2 to the x power. This is an exponential function because it's in that general form of f of x equals a times b to the x power. Okay, so just putting it right there next to it. And you can't write an exponent x in here. So you just have to use some other way, like get the pencil tool or a separate text. And then you could put your exponent of x. All right, but if you're looking to see what a is, okay, so a, here's where a is. So the number that's in the same spot is 4. For b, the number that's in the same spot is 2. The y-intercept, okay, you have a bunch of different ways to figure this out. To figure out the y-intercept, you can look at your graph. Where does it cross the y-axis? You can look at your table. What value of y, or f of x, do you get when x equals 0? You can also remember that last week I told you that in an exponential function, the y-intercept is always the same value of a. Okay, so if I look at the graph, it's crossing at 4. If I look at the table, it's the ordered pair 0, 4. If I look at the value of a, it's 4. So there's lots of different ways to think about it. You can write your y-intercepts as the ordered pair. One way to do that, 0, 4. Or you can even just say it's 4. Okay, they're both acceptable because when you write it out as an ordered pair, x would always be 0 no matter what y-intercept you're talking about. The last part of this review slide, the end behavior as x approaches negative infinity. Okay, so where is negative infinity? That is, if you start at the origin, it's going to the left, right? So as I move this way along the x-axis, what's happening to my graph? It's getting closer and closer and closer to what? 0. Yeah, 0 is right. I also saw Angel typed in a equals 4 and b equals 2. That's also correct. I didn't see it. I wasn't on the right slide or tab. I have like 20 tabs open, literally. Okay, so we're going to put a 0 right here. Approach is 0. And then as x approaches positive infinity, when you talk about positive infinity, you could put a plus sign in front of it to be like very specific. Okay, if you don't put a plus sign, that's implied you're talking about positive infinity. If you mean negative infinity, you have to put the negative sign in front. So now, as we move along the x-axis this way, what's happening to my graph? It's getting closer and closer and closer to what? What should I put here? What's happening to this black graph, this line here? As I get further out, the x values go further out, this is getting closer and closer to positive infinity. Okay, so this is the review slide. You have to understand this to move on with this lesson because our lesson is now taking this and applying it to real life situations. So do you guys have any questions about the review slide? Go ahead, Angel. How did it get 4.2? Right here, this 4.2? Okay, that was given. Good question. So the information that was given was that this is the exponential function that we're going to make a table for. Okay, we did that. We made a table for it. We also graphed it. And we also filled out this information for it. Okay, so we started with this, and then we did all this other stuff just because this was given. And that's like the kind of problem you might have on Friday. Like, here is your exponential function, and it'll ask you questions about it. Okay, it could ask you any of these things about it. So you should try to understand all these pieces that it could ask about just this given that. Best way to do it, go to Desmos, type it in, make a table, look at the graph, evaluate it from there. Yes, Desmos is allowed and encouraged, okay? So, you know, if you're proficient with this, I mean, it does take a little bit of getting used to and learn. There's a learning curve with using Desmos. But yeah, this is a tool. So in math, we use tools to help us do math, and this is one of the tools that you're allowed to use, and it's an encouraged tool to use. All right, we're going to go to our next slide. So, vocabulary for today. This is our exponential growth model. It's a function that increases with time, and it looks like what you see here in green. Y equals A times 1 plus R to the t power. So this is following that same basic exponential general function form. What's different here is we still have A. Instead of f of x, we have y, but f of x and y are interchangeable. In the parentheses, instead of just b, we have 1 plus r. For our exponent, instead of x, we have a t. So you can see what these different letters mean over here. A is going to represent the initial amount. B, which we would usually have in the parentheses, is now 1 plus r. And that's representing the growth factor, where r is the growth rate and t is the time interval. So over a period of time, this is what we would use when something is increasing, a function that is exponential and increasing. Conversely, if a exponential function is decreasing over time, then it is a decay model. And our formula for that is different just by what's the operation inside the parentheses. So now we have a subtraction sign. Okay, y equals a times 1 minus r to the t power. Again, a is the initial amount. B represents 1 minus r, which is the decay factor. R is the decay rate, and t is the time interval. So we're going to be using these in real-life situations to see what would happen over a period of time. So here's our first problem we're working out that's new. So baseball cards, hopefully you've heard of those before. I don't know how popular they still are, but you know, they used to be popular, and I'm sure they're still worth tons of money if you are still a collector of these things. So a baseball trading card is sold for $2, and its value increases by 8% each year after it is sold. We're going to find the value of the baseball trading card in 10 years. So this is exponential. Every year, its value is increasing based off of the previous year's value. Okay, so and that previous year's value changes every single year. So it's constantly getting worth more and more and more money at an exponential increasing rate. So we're going to use the function for exponential growth, y equals a times 1 plus r to the t power. So that's what we have written here, y equals a times 1 plus r to the t power. And then we're going to plug in the values we need. So first, we're going to write the growth function, and we're going to leave the variable t as t. And then after, we'll plug in the value of t, which is 10 years, here to evaluate it at 10 years to find out how much it'd be worth approximately. All right, so we have to figure out what is a, what is r. A is the initial amount. R is the growth rate. So on your slide, you can draw on this. I'm going to underline some stuff. So our initial amount is here. The baseball trading card is sold for $2. So that's my A. I guess I could just type it right here. A equals 2. I'll put it right there. Put it anywhere, really. Okay, so in this box, I'm going to have a 2. And then R is my rate. So my rate, here we're increasing by 8% each year. Now, for R equals 8%, we can't plug just 8% into the equation because that's not a number that we can do calculations with. So I have to convert 8%, yes, Mauricio, to a decimal. So 8% literally means 8 per 100. So this is the same as 8 divided by 100, which is the same as, and you can type this into a calculator, 8 divided by 100, you would get 0.08. So that's how you can convert a percent to a decimal. And then this decimal is what I'm going to plug in right here. 0.08 goes here. I'll make that a little bit smaller. Okay. And then the next step is what Mauricio has here. This is the value of B that he put, 1.08. If I add 1 and 0.08, I do get 1.08. So that's going to be the value of B, 1.08. And then this 2 is just kind of tagging along. All right, so just this part right here, this is the exponential growth function, okay, in terms of t. So we can use now any value of t to find out how much it would be worth after a certain amount of years. And it's asking us for t equals 10 years because we have right here, it says find the value of the baseball trading card in 10 years, the value in 10 years. So this all implies that t equals 10. Okay, so we're doing this for t equals 10. So again, I'm just going to plug in what A is, what R is, and then what T is. And when you're actually doing these problems, you don't have to have so many steps, but all these steps are here. Okay, looks like you guys figured it out in the chat. So all these steps are here just to kind of help you really understand what's going on, but you don't really have to always show all this work. But we're learning a new concept, so that's why I'm showing everything. So 2, and then you can copy and paste what you've already had. Okay, so because it does repeat a lot. Just kind of highlight it like this, then Control C, and then click out of it, Control V, and then you can quickly get, if you're using the same colors as me, you don't have to do all this color coding. I do this to help you see what we're doing. That helps you do that. If it doesn't, don't do it. It's really up to you. Okay, so now I'm plugging in 10. So now that I have all the pieces where they need to go, okay, you know, if you understand all this, you can actually just jump right to this last step that I did here. Okay, A is 2, because R is 0.08 and it's increasing, it's 1 plus 0.08, which is 1.08, and then T is the number of years we're trying to find out for. All right, now when we are calculating, let me add in some text here. When you calculate, where can I put this? just type it here. So when you calculate your answer, use PEMDAS order. Okay, order of operations. Don't forget about that because that will change your order. Parentheses. That's why we're adding these things together, you know, before we do anything else. So they get added together there. Exponents. We're going to deal with the exponent next. And then finally, multiplication. So let me show you again. I want to show you a tool that everybody has, which is the Google Calculator, right? You guys, most of you are on your Chromebook, most of you. And so you can use the Google Calculator app, or you can type in Google Calculator into a Google search, and then it'll bring this one up specifically. So I could show you exactly how to evaluate these expressions using this. When you want to find the power of something, like 1 800 to the 10th power, well, I need to use, if you look at these buttons, I'm going to use this button here, this x to the y power. Now, when we were in Desmos, we had something similar. We had a to the b power, but it's still two variables that are represented as a base and an exponent. And so here it's x to the y. In Desmos, it's a to the b. But in order to use this button the right way, what we're going to do is type the base first. The base is 1 800, 1.08. Okay. Then I click the button x to the y. And you can see it made like a little tiny box here. So now I could type in my exponent of 10. All right, so that's how you use this calculator to evaluate a power. And then hit equals. There's the value. All right. Now I'm going to multiply that value with 2, because that's what I have out front, times 2 equals. There is my approximate value. But we have to round this because it's asking for a money amount. We don't write out our money amount as this. Okay, we want to round it to the nearest cent. So we want to make sure we round to the nearest cent if it is money. So just put that there to help you remember that. 4. So the dollars are 4. Actually, yeah. To get this cursor right where you want is difficult sometimes. $4 and 30, is it 31 cents or 32 cents? When you round, yes, Angel. Yes, Mauricio. 32. You got to look next to the number that you're rounding. I'm rounding the 1. Next to it is a 7. So that means this 1 turns into a 2. Okay, so it's $4.32 approximately. This word approximately is also a symbol when you're working with equations. Notice that over here, guys, I put my answer in. The equal sign went from a regular equal sign to a wavy one. This is called the approximately equal to sign. And if you ever round, then you use this symbol. If you do not round, you keep it as equals. But if you round, you use this symbol. All right. So where are we on time? Because I always feel like I take too long. And we still have another slide. I think we have 5 minutes, right? Yes, we do have 5 minutes. So hopefully I'll get through all of this next slide in 5 minutes. Remember, this is being recorded, so you can always go back if I go too fast. And I encourage you to go back and watch the video if you don't get it. Watch it again. So we're going to move forward now to the next slide. And if you need to come back to this, I'll put you in student paste at the end. So we're going to go to our last slide now, slide 6. We have a car. This is the other type of real life situation. Okay, where is it? Right here. So we just looked at a growth model. Now we're going to look at a decay model. So we're going to be using this formula. The only difference is we subtract R. We subtract the decay rate. That's it. The growth model you add, with the decay model you subtract. So here we go. The value of the car is depreciating at a rate of 5% per year. That's our rate. Let me try to be consistent and use the same colors that I used on the other one. So I used purple for rate. And I used green for A. Okay, that's fine. I could get back to the right screen. Okay, so purple for rate, depreciating at a rate of 5% per year. A, the initial value. The car was worth $32,000 in 2010. And we want to find the value of the car in 2013. So it doesn't tell us what T is exactly. You have to use the fact that we started with this year and we ended with this year. So T is 3 years. So it does tell us later on. But that's why it's 3, because 2013 minus 2010 is 3 years. For your value of A, now I'm going to go to text. A is equal to $32,000. So something I noticed with HMH, this assignment you're going to have, if you don't put in the comma, it might mark you wrong. Kind of stupid, but that's just what it's deciding to do. And with our R here, R equals 5%, which equals literally 5 per 100, which equals 0.05. Okay, so these are the values we're plugging in. We're going to put A first as 32,000.
What are you doing? 9:40.
So this is going to be 32,000. And then this is going to be 0.05. Okay. And now when we rewrite this, remember, you could just click on something and control copy and then click out and paste it and it'll go the same color. We have to simplify this. What is 1 minus 0.05? Use a calculator. 1 minus 0.05. Yep, you're right, Mauricio, 0.95. So that's what you're going to type here, 0.95. That was the only difference. We got to subtract when it's decay or decreasing. And now we're going to plug in these values. Our exponent is 3 because it says in 3 years. So T equals 3. And now we just have to evaluate this. All right, so you're going to use your calculator. So try that. What do you get? Remember, PEMDAS order. So we're going to do this to the 3rd power first. And at this point, I am going to put you on student pace so you can go back. Anything you need to. Because I'll forget if I don't do it right now. Remember, type in the base first, and then the x to the y power, and then the exponent, and then equals. Then you multiply by 32,000. Now, when you write your answer, use a comma, because just to get used to HMH, it's not going to take your answer without a comma, I don't believe. I was doing that to one of my students yesterday. So use a comma, but we're going to come over here. Now it's the same thing. If you type it one time, you just control copy, click into a new text box, and paste. Like that. You guys have any questions?